We are going to go through the process of setting up vowel today. I have already cloned the vowel stack repository to my local machine. You can find this repository in the vowel GitHub organization under the name stack. I will run through the setup manually, but we highly recommend using an agentic coding tool like Claude Code, Cursor, or OpenCode. I will start by initializing the submodules. These submodules contain the various components of the vowel stack: our demos, the client SDK, the core repository for the token issuer, and our real-time voice engine. Now that those are checked out, I will proceed to install the necessary dependencies. Next, we need to build the various vowel components. There is a helper build command included in the stack's package.json file that takes care of this automatically. The build for the client is complete, and now the system is building the core UI. With the builds finished, we can start configuring our environment variables. We need to copy the provided environment example file. This contains all of the possible configuration options for the vowel stack. These variables are read by Docker Compose to determine the parameters passed to the various containers, as shown here. We will populate this file with an API key from deepgram and one from Grok. First, navigate to deepgram to generate a new API key. I will rotate these keys after recording this video, so there is no security risk in displaying them. With the deepgram key in place, we will now get our API key from Grok. Copy the Grok key and paste it into the corresponding field in the environment file. It is critical to update the LLM provider setting to Grok in order to use this key. We also need to disable the standalone voice activity detection, or VAD. The SILERO-VAD is typically used when your speech-to-text provider does not have built-in voice activity detection. DeepGram's speech-to-text pipeline directly integrates voice activity detection, which determines exactly when the user starts and stops speaking. Because DeepGram handles this within a single AI model, it does not need a separate VAD pipeline. Therefore, we will disable SILERO-VAD in the configuration. Now that the provider configuration is complete, let's review the documentation for the next step. We now need to generate our secure encryption keys. These are used to encrypt the stored API keys in vowel, as well as the engine API key and the JWT secret. Since these strings can be easily generated, I will have my AI agent create them for us to save time. I will prompt the agent to generate the necessary 64-character hex strings. The agent will use OpenSSL to auto-generate randomized secure keys for our configuration. The AI has finished generating the keys and inserted them directly into our environment file. Let's check the documentation to ensure we haven't missed anything. It looks like we have completed all the prerequisites, so we can go ahead and start the stack. Running the stack up command triggers Docker Compose to build and initialize all of the vowel containers. The containers are now live. Let's open the vowel core UI in the browser. vowel core is the component of the self-hosted stack that manages issuing ephemeral tokens to vowel voice applications. These ephemeral tokens contain signed configuration data, system prompts, and all the entitlements required to access the real-time voice AI engine. In the test lab, we can generate a sample vowel token and run a quick validation test. Hello, can you hear me?
Hi, I can hear you loud and clear. How can I
As you
help you
can
today?
see, the real-time AI voice engine is working properly. Next, we will set up the basic e-commerce demo by connecting it to our self-hosted vowel stack. To do this, we need to create a local environment file in the demo directory and paste in the configuration required to access the locally hosted stack. Essentially, this tells the demo application to route requests to the self-hosted version of vowel and defines the API key to use. We will return to our app dashboard in the core UI and copy our newly created publishable key. With the API key pasted in, we can start a new terminal session, navigate to the demo folder, and run the app. First, we need to ensure the packages are installed. The packages are installed. Now, let's start the development server. The development server is up and running. Let's open it in the browser. We can click the microphone button to start interacting with the demo, making sure to grant the browser microphone permissions. Take me to the search page, please.
Okay, navigating you to the search page now.
And there we have it. The vowel self-hosted stack is fully up and running. Just to quickly recap what we covered today, we started by initializing our submodules and installing our packages. Then, we configured our environment variables, plugging in DeepGram for speech-to-text, Grok for our LLM, and having our AI agent generate our secure encryption keys. Once our config was set, we spun up the Docker containers, jumped into the core UI to create our new app and API key, and validated that everything was working perfectly using the built-in test lab. Finally, we passed those credentials into our local demo environment and got to interact with the voice-enabled e-commerce app in real time. Just to quickly recap what we covered today, we started by initializing our submodules and installing our packages. Then, we configured our environment variables, plugging in DeepGram for speech-to-text, Grok for our LLM, and having our AI agent generate our secure encryption keys. Once our config was set, we spun up the Docker containers, jumped into the core UI to create our new app and API key, and validated that everything was working perfectly using the built-in test lab. Finally, we passed those credentials into our local demo environment and got to interact with the voice-enabled e-commerce app in real time. Thanks for watching, and happy building!